Hello everyone, welcome back to another Math Challengers video. Today we're going to start off with question 11. If you need to read a question, pause the video here. Alright, so before we begin, I'm going to start off by drawing a diagram. So it would look something like this, where this is a section of the Earth with a radius of 6400 kilometers, and the airplane is flying 10 kilometers above the surface of the Earth, essentially, and the ship would be on the surface of the Earth. And what we want here is the airplane would be here, and the ship would be here, and the ship needs to be able to see the plane, and this distance here is 10 kilometers. Of course, it's not drawn to scale, but this will give us a pretty good idea of what we need to do here. And one really important thing to note is that this angle right here is a 90-degree angle. The ship can't see below the horizon, and so the lowest angle that the ship can see is straight out horizontally, which would make an 90-degree angle with the radius going to the center of the Earth. So here we go. Actually, after you set up this diagram, you see that this is actually quite a simple Pythagorean theorem question. And you're trying to find this length over here. So all that you really need to do is say that this distance, let it be d, is equal to the square root of this length, which is 6500 squared, minus this length, 6400 squared. And your answer is 358 kilometers. And that's your final answer. Alright, moving right along to question 12. This one, as you can see, is related to question 11. If you need to read a question, pause the video here. So for this question, it is actually sufficient to consider the plane and the ship as traveling along a flat surface, because we're only caring about their distance after 1 minute after passing each other. And so the curvature of the Earth isn't significant enough to affect our answer, or at least it shouldn't be. So I'm going to draw a graph here, or a diagram here, and this is the surface of the Earth, and the plane is traveling at this height here, which is 10 kilometers. And the ship is traveling over here towards the left, let's just say, at 40 kilometers per hour. The plane is traveling here in the opposite direction at 920 kilometers per hour. So that's all good. And all that we really need to care about is where is the ship and where is the plane after 1 minute. And for that, we want to find the distance that they travel in a minute instead of in an hour. And a minute is 1/60th of an hour. So all that we really need to do here is I'm going to erase the speeds here, and I'm just going to put in that this distance is 920 over 60 kilometers. And this distance here is 40 over 60 kilometers. And now you see again that this is simply a Pythagorean theorem question. This one might not be as clear as the previous one, but I'm going to make it a bit clearer by doing this. So this length here obviously is also 40 over 60 kilometers, and this one is still 10 kilometers. So what we want to find is the hypotenuse, and we can do that really easily through the Pythagorean theorem. And you can use calculators for the co-op section, and so you would get an answer of 19. Alright, moving on to question 13, which is also related to question 12 and 11. If you need to read a question, pause the video here. Alright, so in this question, we need to put the curvature of the Earth back into account. And drawing a diagram here, what we have is a slice of the Earth. The radius is, again, 6,400 kilometers. And the angle here is 5 degrees. And a ship, let's say, is traveling in this direction at the same speed as it was in the last question, 40 kilometers per hour. So clearly the key to answering this question is finding out the length of this arc. And the way we're going to do that is thinking about how to find the circumference of this circle. Or in this case, the circle is technically the Earth, and we're taking a slice of it. And the circumference is obviously 2 pi r. So in this case, it would be 2 pi times 6400. And instead of the whole circumference, we're taking a slice of it. And this slice is 5 degrees. There are 360 degrees in a full circle. So a 5-degree slice would be 5 over 360 of the entire circle. And so what we want is that the arc length for this particular question is equal to 5 over 360 times the circumference. This gives us an arc length of 1600 over 9 pi. And all that we need to do now is divide this arc length by the speed of the ship to get how long it takes for the ship to travel this arc length. And so our final answer is going to be 40 over 9 pi. And we're going to want to approximate this. And so the answer that we're actually going to write down is 14. So 14 is our final answer. Alright, moving on to question 14. If you need to read it, pause the video here. So to solve this question, you can bash it out. Just spend some time listing out all of the different possibilities that you can think of. But if you're not being methodological with it, then it's very likely that you're going to miss some of the answers. So here's another way, a more controlled way of doing this question. So over here, we have 1 over a plus 1 over b equals 1 over 8. I'm going to multiply both sides of this equation by 8ab. And I will get 8b plus 8a is equal to ab. Rearranging gives me ab minus 8 minus 8a minus 8b is equal to 0. Now the next bit is a little bit tricky. What I'm going to do is add 64 onto both sides. And the reason I'm going to do this is because now I can factor the left-hand side as so. A minus 8 times b minus 8 is equal to 64. So if you didn't know why I added 64, you can still see that without adding the 64, we have ab minus 8a minus 8b. So the factors that we want on the left-hand side are a minus 8 and b minus 8. Now, of course, if we expand a minus 8 times b minus 8, we would get the left-hand side over here. And we see that we need to add 64 to both sides in order for it to work. And the reason this factorized form is great is because linear terms are much easier to deal with than quadratic terms like this one or fractional equations like this one. Because what we can do here is say a and b are both integers. And so a minus 8 and b minus 8 are both integers as well. What that means is that we have two numbers here, a minus 8 and b minus 8, and they multiply to give 64. So all that we really need to care about now are the factors of 64. So the factors of 64 are 1, 2, 4, 8, 16, 32, and 64. It's actually a perfect power of 2. And so we can just list out its factors that way. And we can see that for each pair of the factors of 64 that multiply together to give a minus 8 and b minus 8, or 64, we can get a unique pair of numbers for a minus 8 and b minus 8. So let's do an example here. Let's say we chose 4 and 16 to be our pair. See that 4 times 16 equals to 64, so this is one of the pairs that we can choose. So we can let 4 equal to a minus 8 and 16 equal to b minus 8. So then we will get that a comma b is equal to 12 comma 24. And if you double check, indeed 1 over 12 plus 1 over 24 is equal to 1 over 8. It also states in the question that the ordered pair xy is different from the ordered pair yx, and that integers can be either positive or negative. Alright, so now I'm going to list out the different possibilities here. So writing out the factors of 64 again, we see that we can pair these things up as so: 1 with 64, 2 with 32, 4 with 16, and 8 with itself. Now for these three pairs over here, the answer is actually pretty simple for these pairs, because what you can have is 164, just taking this as an example, or 64 comma 1, or negative 1 comma negative 64, and negative 64 comma negative 1. Each of these would give you a corresponding pair of A's and B's, and they're all going to be different from each other. So these are pretty simple, and there are 3 of these pairs, and so that already gives us 12 solutions. So you know we have 12 solutions. Now, the 8 case is a bit different from the other ones. And let's see what happens. So the 2 pairs that can happen are 8, 8, and negative 8, negative 8. Obviously, switching the 2 8s doesn't matter because they're the same. And let's see what values of A's and B's these 2 pairs would give us. 8, 8 would give us A comma B equal to 16 comma 16, which we can check works. Now, for the negative 8 case, it will give us A comma B equal to 0, 0. This is really bad, because you can't do 1 over 0 plus 1 over 0 equals 1 over 8, right? And so this is an extraneous solution. This is a big no-no. This is not a solution. And why did we get here? How come we have a solution that gives us 0 comma 0? The reason is we multiplied both sides of the original fractional equation by 8ab. Now, this is completely valid if both a and b are non-zero. But of course, we couldn't have been sure that a and b are non-zero. So if a and b were both 0 and we multiply both sides of the equation by 8ab, then we're invalidating the original equation. And that's how the 0, 0 becomes a solution in our new equation, even though it isn't technically a solution for our original equation. So if you add all of these together, there are a total of 13 solutions, so 13 is our answer. Moving swiftly on to the last problem of the day, problem 15. If you need to read the problem, pause the video here. Now this problem might look hopelessly confusing at first, but what we really got to do is just draw a few more lines and it should become a lot clearer to us. So one line that I'm going to draw is over here, or rather 2 lines I suppose. And it looks pretty squiggly, but it's supposed to be a continuation of O2 to this point here. And maybe this will make things a lot clearer for you. What we have here is a tangent line to the circle O1, and all tangent lines to circles are perpendicular to the radius at that tangent point. So we can actually draw this in and draw this in as well. So what we have here is a rectangle, and with a rectangle we know that the length on this side is the same thing as the length on that side. So this length is 5. Now let's look at what length we're trying to find. We want to find the distance from A to O2. Drawing this in, we see that this is actually the hypotenuse of this right angle triangle here. And the good news is we already know what this length is. Now all that we need to know is what this length is. So we try to find what this length is, and since this is a rectangle here, this length is equal to this length. And so what we have is we can find this length here based off another right angle triangle like so. And then we can go ahead and find the value of AO2. So what's the length of the green one? Well, let's see. The hypotenuse has length 20. And the other leg has length 5 plus 7 plus 7, which is 19. So this will give us the square of this green length here. Now we don't actually need to square root it, because in the next step, we're going to use the square of this length and add that to 14 squared, which is this length over here, to get the square of the length of AO2. And this number on the right turns out to be 235, so AO2 is equal to the square root of 235. And this answer is in the exact form that they want us to answer it as, root n, where n is an integer. So this is our final answer, square root of 235. That is all from me today. Thank you for watching, and I'll see you next time.